Hello, Flat Earth researchers, debaters, and debunkers. A quick question for pilots and all those who believe that geometry undeniably proves that we are living on a spinning ball. Now, I am not disputing the mathematics that can be used to accurately navigate and get people safely to their destinations. What I want to know, though, is where exactly is north when you are flying over a globe? Here we have an aircraft flying above the equator, and it should be flying level, so it would be level with the ground directly beneath it. And I want to know, which way is north? Is it directly ahead of the aircraft, as we see with this green line here? Is it on a tangent that has a line coming from the aircraft touching the edge of the ball? Or is it pointing directly at the North Pole? Of course, this illustration is not to scale, but then nothing ever really is when we try to look for real pictures of the Earth from space or try to illustrate what we actually see and experience in real life and compare that to how it looks on a 2D screen or piece of paper using calculations. So, first of all, there are compasses. Which way is a compass really pointing? Is it pointing to the north or the south? Is it pointing to a spot on the Earth, or is it following a line along the Earth? Either way, a compass needle, as far as I know, does not strain to go through the floor of the compass when we are down south and the compass is trying to point north. On top of that, how many poles are there, and how can one or two poles dictate where the top or the bottom of a sphere is? Because really we know that a ball does not have a top, a bottom, or a side. It just has one side. So when the globe was put together, fabricated, of course, given that there is a North Pole, a South Pole would have to be created in order to have something opposite the North Pole. Otherwise, you simply cannot make your sphere. So apart from not really knowing how compasses work and which way they are really pointing, we also have a major issue when we try to decide which heading the pilot is actually using. If the pilot is heading north along the green arrow, then south is directly behind them. Now this is somewhat justifiable as being what we observe. If you want to get down to the nitty-gritty of the degrees of difference between the horizon and eye level, but most of the time when we are flying high, say 40,000 feet, the horizon is rarely a very clearly defined line. It's usually a kind of blur of whiteness, or we have lots of cloud cover, so it's very, very difficult to really clearly define exactly where the horizon is when we are assuming that what we see is because we are flying level with a very large Earth below us. But as we are told with common illustrations of how things work on a globe, we are usually told that we are heading or looking into a bulge or down a curve. So this would be the blue line, which for which there is quite a significant difference between the angle heading straight ahead and the angle down to that, what would be assumed to be a horizon line because of the tangent touching the edge of the sphere. But of course, when that comes to looking out the back, we should not see a horizon at all when we look south. So if you're a pilot following that blue line north, and you are justifying that by saying that, well, the horizon is a certain number of degrees below eye level, well, all you have to do is look out the back and look south, and the horizon to your rear should be much, much lower, because you are effectively pointing your nose down, then your tail should be going up. But if you are going to fall back on the default argument of the Earth being so massive that you can't tell the difference, then in that case you cannot go and argue about the minute differences that we might be seeing between the horizon and our eye level. And then we come to the third heading, the red north heading, directly at the North Pole, which puts our south way off in the opposite direction to the Earth, up in space, for which there would absolutely be no horizon whatsoever to be seen out the back of the plane. And of course, if we are heading in this kind of direction, we are actually heading into the Earth, so we are really going downwards at something like 45 degrees. And of course, when we understand that the circle of 360 degrees and triangles with angles that add up to 180 degrees, we can understand how the manipulation can come about. And we can understand that there is mathematics associated with how our eyes work and the laws of perspective, the way light is reflected into our eyes from the surface, and how it is bent or channeled in a cone inside our eyes. So we must consider the observations and the science behind the instruments we are using to make these observations, our eyes, and how they affect what we see around us, and whether what we see can be justified with geometry of circles and lines and triangles on a piece of paper. So I'm hoping that pilots can take this question seriously and just give us an answer. Which north do you follow, and how do you justify what you then see or don't see in a southerly direction if you are really traveling over a spinning ball Earth? Now, regardless of which north is the one used by all pilots, this leaves a massive discrepancy and a massive clue as well as to how the flat Earth has been projected into a globe, and how we have been conditioned to ignore what our eyes and senses tell us. You see, once you have chosen one of these northerly directions, you're still left with two. So we have between the green arrow and the red arrow about 45 degrees. Choose one of those as your true north heading, but then that still leaves you with something between 45 degrees, 23.5 degrees. Think about that. Where has the missing 23.5 degrees gone? Where has it been put to project the flat Earth into a globe and justify all the anomalies that go with having to believe that we are on a spinning ball Earth? Thank you very much.